Now, our next question is about antenna and how it behaves in the communication system. What should be the exact height of the antenna? So, these all facts are to be discussed when we discuss about antenna. So, antenna, if we take up certain calculations, goes to a height of 25 kilometers, but that is not possible. We can't construct an antenna of 25 kilometers. That's why we try to shorten the length of the antenna and it can be brought to about 300 meters. So this type of explanation we have to come across regarding antenna. Now, we are coming towards antenna. That is, an antenna is basically a small length of a conductor. When we use the conductor, we are referring to that is good conductors or the metal conductors or the alloy conductors. Because when we speak alloy conductors, their alpha is small. That is, change in resistance per unit resistance per degree centigrade rise in temperature will be low. And conductors must be normally made from alloys. So that is used to radiate or receive electromagnetic waves. So we will highlight electromagnetic waves. The electromagnetic waves are those waves which constitute electric and magnetic field, but they are not deflected by electric or magnetic field. And their speed is about speed of light, that is 300 million meters per second, that is 3 into 10 to the power 8 meters per second. Moreover, electromagnetic waves, they can be communicated in the medium as well as without the medium. Their speed is not affected. So these waves are transverse in nature and they are very important waves to carry out the message. So next is, it acts as conversion device. It acts as conversion device. All the transmitting end, at the transmitting end, it transforms high frequency current into electromagnetic waves. When we speak high frequency current, we are referring to the alternating current or sinusoidal current, and it is converted into electromagnetic waves. All these things are carried out in one of the devices called oscillator, and normally it was first of all carried out by Hertz. That's why this whole program is taken into, that is the Hertz oscillator. So Hertz oscillator generates carrier wave, and simultaneously from the microphone electrical signals are generated. They superimpose the carrier wave, and the new wave, resultant wave, is supposed to be the modulated wave which is to be transmitted, and then it is received at the receiver end by antenna. At the receiving end, it transforms electromagnetic waves into electrical signals. That is called processing. That is fed into input of the receiver, and receiver is in the form of transistor. Earlier, about 30-40 years back, the receiver were in the form of a diode wall or a triode wall. Now, our new technology is using the integrated circuits, which are using NPN transistor or PNP transistors. A dipole antenna, when we use this term dipole, it means that is, it has got one pole positive, other is negative. A dipole antenna is omnidirectional. Omnidirectional means receiving signals from all the directions, whereas the dish antenna is highly directional. So highly directional means space communication. The length of dipole antenna is usually calculated by formula lambda by 2. Now, what are the two basic modes of communication? Now, we have to go through with the methods of communication. Now, two basic modes of communication are as follows. Number one is point-to-point communication. In this mode, communication occurs over a link between a single transmitter and a receiver. For example, telephony. So here there will be a single transmitter and receiver, but broadcast mode, when we use this term broadcast mode, in this mode, a large number of receivers are there. So it is not necessary that only one receiver will work. There can be plenty of receivers, because broadcast means that there is a band of the frequencies which are to be accommodated, and that's why we use large number of receivers, and they are linked to a single transmitter. So in case of broadcast mode, we will find that there is a transmitter, but that transmitter is concerned with, or it is connected to many receivers. For example, radio and television. Because for the radio and television broadcast, there must be a broadband. That is, there must be many frequencies operating simultaneously. Now we come towards, that is, describing, that is, various terms commonly used in describing the various electronic communication system. So electronic communication we have followed, that we have to communicate a message to the receiver, and communication is carried out at the transmitter, but it is sent through the free space, and receiver will process it. Then what are the various terms we are using in describing the electronic communication system? So first of all, we come towards the terminologies in the electronic communication system. And first, basically, the first term which we are commonly using is transducer. So transducer is nothing, it is converting energy basically. So we will say like this, a device which converts energy from one form to another is called transducer. Because energy is neither created nor destroyed according to the law of conservation of energy. Therefore, transducer's function is, that is, to convert one form of energy into another form. For example, microphone, it converts sound signals into electrical signals, because the radio wave will not respond directly to the sound signal, or carrier wave is not responding directly to the sound signals, because there is a lot of difference in their characterizations. Sound signals has very low velocity, and moreover, their amplitude is not also comparable with the radio signals or the carrier signals. But the carrier signals, they have very high velocity. Normally it is 300 million meters per second, or about 3 into 10 to the power 8 meters per second. So microphone is one of the devices which converts sound signals into electrical signal. Now during conversion, we find that there is slight loss in energy also, because total transformation is not possible. Total transformation is not possible. So now we come towards the definition of signal. What basically is a signal? So signals are classified into two categories, like one is an analog signal and other is a digital signal. Analog signal is not very beneficial, so normally the communication is carried out from the digital signal. So the concept is like this: signal, it is the electrical analog of the information produced by the source. It may be defined as a single valued function of time. That is the function of time, ft, that conveys the information, and which at every instant of time takes a unique value. Signals can be analog or digital. The unwanted electrical signals which get interfered with the information signal during its propagation through the transmission medium constitute noise. So whenever we make communication, there can be production of noise, and it has to be removed also. So we use a different technology for that. Consequently, a distorted version of the transmitted signal reaches the receiver. So it means we have to make arrangements to remove this distortion and the noise at the receiving end. So we have got the filter circuits at that point, and filter circuits are responsible for having a very clear version of the communication made. Now we come towards the transmitter. It is a device which processes a message signal into a form suitable for transmission and then transmits it to the receiving end through a transmission medium. I have explained earlier, transmission medium will be a free space. When we use this term free space, we are referring to air or vacuum. Its three basic components are message signal, the generator, message signal generator, a modulator, and antenna. These are the basic three parts. So three components are message signal, generator, a modulator, and an antenna. Now we come towards the receiver. It is a device which recovers the original message signal from the signal received at the output of the communication channel.